want to design a synchronous counter or any random sequence generator with the help of the JK flip-flop or any type of flip-flop. So here is the guys. So this one we will be guiding you to do those things. So let's discuss how the synchronous counter can be designed. So if they are giving, we can analyze. So if they ask us to design, how that can be done here. So let's see here. So we everything we know as like we will be drawing a table. So the states what are need to be mentioned clearly observe. So that will be helping you guys to understand it very neatly. So here if you see here we are having the eight states. So there will be three different things we have to take it. Means 3 flip-flop is needed, right? So that's what I am writing here. So please wait, let me complete this table so that you guys can understand it. So here this one is present state. So current state. So this is present state. So this is next state. So here if you see there is a 3 input we needed, right? So let us first design this one. So we are taking in this order Q2, Q1, Q0. So Q2, Q1, Q0. Okay. So present state we are starting from 0 0. The next state will be 0 0 0 1. Okay. So present state now this state will come here. So 0 0 0 1. This will be 0 1 2. So this is 2. So 0 1 0. This will be 3. So 0 1 1. So here will be 0 1 1. This will be 4. So 1 0 0. So 1 0 0 here. So here will be 1 0 1. So 1 0 1 1 1 0. So 1 1 0. Here will be 1 1 1. So 1 1 0 0 0. Okay. So simple guys. So here we know that is in JK flip flop. So let us term the inputs, that is J2 K2, J2 K1, J0 K0. Okay. So these are all the things that we have to take into account. So this is an excitation table output. So here we have a present state and next state. So let us take a excitation table here. So Qn plus 1. So then how the JK will be changing. So if it is 0 0 0 1 1 0 1 1. So there I asked to you guys to remember the excitation table, right? So for this only this is needed. So here the reverse XX 1 0. Okay. So here if you see the particular input, that is Q2 Q2. So when Q2 is from 0 to 0. So when Q2 is 0 to 0, the J and K input will be 0 and X. Okay. So when the here also same. So this is also same. So 0 and X. Third also same. So 0 X. So here you see 0 to 1. The change is starting from 0 to 1. Then J is equal to 1. K is equal to X. So similarly, if you fill rest of things, so let me fill it. So if you guys also need to try means, please pause the video and try to fill it. So let me completely fill this box, each things. So this is a sample of matter. This is I'm just picking from the excitation table. So nothing more here. So X is 0, here X1. So here it is 0, X, 1X, 1X, X is 0, X1. Okay. So here it is 1X. So this is changing from 0 to 0. So it means there is a 0. Here you see 1 to 0. So that is an X1. Here it is 0 to 1. So 0 to 1 means 1 and X. So here 1 to 0. So X and 1. So here 1X, X1, 1X, X1. Okay. So this is how this filling. So I just took from this one and I filled it. So I hope this table is fine for you guys. So now what we have to do is that we need to find out that each equation. So J2 what is the equation, K2 what is the equation, everything we have to find. So for that let me copy this table alone. So this is only needed for now. So let me add in the new page. So let us now find the K-map for all the things. So I am asking you guys also to do. So it will be very helpful for you guys to practice these things. So you see fundamentally K-map and those things only behind every full digital systems depends on that only. So you see how crucial the invention of K-map is. So without K-map it will be very difficult for you guys to analyze these things, right? So this is. So let me take the first one, that is J0. So here let us try to find out for J0. Okay, J0 means this one, this J0. So wherever J0 is 1 means, so this is from the table we have to take. So this is 0, this is 1 2 3. From the present state we have to take these things. Okay. So wherever the table is 1, the j0 is 1, that thing we have to mark here. Wherever the k is 1, that will be marking as a secondary. Okay, so let us first let me add the j0 values here. So j0 at a 0, j0 will be 1. At next level it will be x and x 1 1 x 1 and x. Okay, so this will be q2, so this will be q1, this will be q0. Okay, so 0 1, so 0 0 0 1 1 1 1 0. So if we find out the equation for this one, then j0 which will be equal to this one. So how we can map is that we can take all the things. So we can map, how we can map is that even we can take the don't care condition here. So if everything is 1, so then the j0 will be equal to 1. Okay, so let me draw another one and then let me fill it rest of thing, because it's a normal k map, right? So let me fill it faster. Okay, so this is for k naught. Okay, so as it is q2 q1 q0, so 0 1 0 0 0 1 1 1 1 0. So wherever it will be is it is also having all the value. So let me write it x1 1x x 1 1 x. So this is also all the one, so mapping k naught will also be 1. So let me write out rest of the things equation. So what will be j1 will be q0. So I am not going doing the k map, so you guys please take that as a homework and do it. So k1 will also be q0. So j2 which will be q1 q0 and k2 which will be equal to q1 q0. Okay, so this is the 6 equations that we are having. So let us now design the circuit. So this is the 3 flip-flops. I'm arranging it sequentially. So here this let me first we know the j0 and k0 is 1. So let me connect it directly. Okay, so this output will be 1, and clock, this as it is and synchronous one, so clock will be applied to everything sequentially. So let me complete the clock thing for everyone. So this is what the difference between sequential and synchronous and asynchronous counters. So let me first name the things. So this is 1, so this is j0, so this is an clock. So clock will be generally up trigger only. So here that is will not be maintaining anything. So even it is down negative trigger or positive trigger, the output will be same, because our analysis is quite different. So q0 bar. So this will be j1 k1. This is the clock. So this is the clock. So j2 k2. So q2 bar, q1 q1 bar. Okay. So what will be the equation for j1? j1 is q0 and k1 is also q0. So the thing directly the output is taken from here and get wired to both. Okay, so this is same. So what will be the equation for j2? j2 is q1 q0, the AND of q0 and q1. Okay, so let me add the AND gate here. So both are AND and that output is given here and the same output is taken given here. Okay, so then this output is taken this side. So if we have this circuit as designed like this, this will be counting from the sequentially counting from 0 to 7. That is what this is synchronous counter. Okay, the synchronous counter design will be quite difficult, so that you guys know, right? So that is similar to what. So here the Q0 toggles at every input. So it will toggle at every input, every clock. So Q1 toggles whenever Q0 is equal to 1. So the clock is applied. So whenever Q0 is 1, this will apply. So Q0 will toggle whenever Q1 and Q0 that product is 1. So okay. So this is how it will work. So this is a mod-up counter. So to analyze any synchronous design, always analyze from the rightmost flip-flop. So from this flip-flop we have to analyze. So in order to, this is one shortcut to analyze any kind of synchronous flip-flop. The first input is ready to apply for clock. Okay. So analyze from this right side. So I am like this way we can design any kind of thing. So where everywhere we will be in most of the time the gate question they won't ask us to design. So just they ask us to analyze. So here let us discuss another one counter, that is 0 to 3, 3 to 1 and 2 and 0. So this is a random sequence. So using the D flip flop design this one. So this is the question that they ask. So this is a synchronous. So using D in synchronous. Okay, let's see how we can design this one. So this one is very simple. So like previously how we have done, so similar to that only. So present state, next state, and each thing need to be analyzed. So here the two flip-flops only here, so that will be our discussion of things will be quite easier. Okay, so on D flip-flop, so D flip-flop is one other very easy state. So this is a present state, so this is present state, this is next state, and this is D1 and this is D0. Okay, so 0 0, next state will be 0 1, 0 1, 0 1, 1 0, 1 1. Okay, so this will be 1 0, this will be 1 1, this will be 0 0. So let me draw the excitation table. So excitation is table nothing but the output that is present in the new state. Okay, oh sorry, I have made a mistake here. This is not a sequence counter, so this is a random sequence counter, right? So from 0 0 it need to change to 3. So 3 is 1 1. So 3 from 3 it need to change to 1. So that is okay, I'm sorry, again made a mistake here. So here if you see from 0 0 it is changing to 3. So we have wrote here. So if the present state which is equal to 0 1, then the next state will be equal to 2. Okay, so that only we have to take. So if the present state which is equal to 2, then the next state will be 0 0. So like this way only we have to take. So we should not take this sequence, so that will make us error. So present state is 1 1, that is 3. Then next state which will be equal to 0 1. Okay, so this is how this need to be sequence. Present state we need to take it as sequence, then only the next thing will be this is what we have to analyze like this way only. So even if we change this, the things will work, but for analyzing purpose, like while we are building the K map, it will confuse us, right? So in order to maintain that order, I am use the order from 0 1 2 3 like this way. So what are the state here? That will be the D1's output. So here will be 1 1 0 0. So here will be 1 0 0 1. Okay, so if we use the K map and design the things, so D1's equation will be Q1 bar and D0 equation will be XR of Q1 and this is X and R, right? So X and R of Q1 and Q0. Okay, so if we connect this one, so we will be able to get to the asynchronous counter. So let me design that thing also here. So it will be very easy, right? So here let us connect the clock synchronously. Okay, synchronous clock is connected, and this is taken as a D1. This is Q1, Q1 bar. This is D0. This is Q0. This is Q0 bar. So D1 output is Q1 bar. So here if you see, so this output is taken and this is fed here. Okay, so then D0 input which is equal to Q1 bar which is XORed with this one. So here you see this one is XORed with here. So this one is taken and this is XORed. So this is fed here. So this is how this will occur. So if we do this one, this output will be similar to this sequence. So 0 3 1 2 0. So like this way only it will count. So this is one of the thing how we can design any random sequence. So with the help of this one, how any kind of random sequence can be generated is a very important thing that we have to discuss. So we already got through synchronous counter, asynchronous counter, up down counter, random sequence counter, everything we have analyzed. So I hope now you guys were very good familiar with the concept of counters. So I am suggesting you guys to practice more question. So next class we discuss some kind of previous year gate question in this, so that you guys will have some quite good idea. Thank you guys.